Unresolved references in VLSI, very large-scale integration, design refer to instances of modules, ports, or signals that the design tools cannot find or resolve during the design process. These unresolved references can cause various issues, including compilation errors, incorrect functionality, and timing problems. Causes of unresolved references. Missing or incorrect module definitions. If a module is referenced in the design but its definition is not included in the project, it will result in an unresolved reference. This can happen due to incorrect file paths, missing files, or typos in module names. Incorrect port connections. If the ports of a module are connected incorrectly to other signals in the design, it can lead to unresolved references. This might occur due to mismatched port names, incorrect data types, or missing connections. Hierarchical design issues. In hierarchical designs, if a module is instantiated within another module but the parent module is not defined or referenced correctly, it can cause unresolved references. Syntax errors. Errors in the HDL, hardware description language, code, such as typos or missing semicolons, can prevent the design tools from correctly parsing and resolving references. Library issues. If the libraries containing the module definitions are not specified or accessible to the design tools, it can result in unresolved references. Identifying and resolving unresolved references. Design tools reports. Most design tools generate reports that list unresolved references along with their locations in the design. These reports can be used to identify the specific instances where references are not resolved. HDL code inspection. Manually inspecting the HDL code can help in finding potential causes of unresolved references, such as missing module definitions or incorrect port connections. Library checks. Ensure that the required libraries are specified and accessible to the design tools. Hierarchical design verification. Verify that all modules in the hierarchical design are defined and referenced correctly. Syntax checking. Use linting tools or design tools to check for syntax errors in the HDL code. Impact of unresolved references. Compilation errors. Unresolved references can prevent the design tools from successfully compiling the design, halting the design process. Incorrect functionality. If unresolved references are not addressed, the design may exhibit incorrect behavior or produce unintended outputs. Timing problems. Unresolved references can introduce timing issues, such as glitches or timing violations, which can affect the performance and reliability of the design. Best practices to avoid unresolved references. Maintain consistent naming conventions. Use clear and consistent naming conventions for modules, ports, and signals to avoid confusion and reduce the likelihood of errors. Modularize design. Break down complex designs into smaller, well-defined modules to improve readability and maintainability. Use hierarchical design. Organize the design into a hierarchical structure to manage complexity and ensure proper referencing. Thoroughly test and verify. Conduct thorough testing and verification of the design to identify and resolve any unresolved references or other issues before proceeding to fabrication. Utilize design tools and automation. Leverage design tools and automation features to streamline the design process and reduce the risk of human errors. What are empty modules in VLSI, and what are their implications? Answer. In VLSI, very large-scale integration, design, an empty module is a module that has no internal logic or components. It essentially serves as a placeholder or a container for other modules. While empty modules may seem unnecessary, they can serve specific purposes in certain design scenarios. Common use cases for empty modules. 1. Hierarchical design. Empty modules can be used to create a hierarchical structure in VLSI designs. By placing empty modules at different levels of the hierarchy, you can organize the design into more manageable components. This can improve readability, maintainability, and reusability. 2. Placeholder for future logic. Sometimes, designers may anticipate adding logic to a specific part of a design at a later stage. In such cases, an empty module can be used as a placeholder to reserve space for the future logic. This can help avoid potential layout conflicts and ensure that the design is ready for future modifications. 3. Design verification. Empty modules can be used in design verification to isolate specific parts of the design for testing. By replacing portions of the design with empty modules, you can focus on testing the functionality of the remaining components. This can help identify and address potential issues early in the design process. 4. Customizable templates. Empty modules can serve as templates for creating custom modules. By instantiating an empty module and adding the desired logic inside, you can quickly create new modules based on a common structure. This can streamline the design process and reduce the risk of errors. Implications of using empty modules. Area overhead. While empty modules may not consume significant area themselves, they can introduce additional overhead in terms of routing and wiring. This is because the design tools need to create connections between the empty module and other modules in the design. Performance impact. The use of empty modules can potentially impact the performance of the design, especially if they are used excessively or in critical paths. This is because the additional routing and wiring can introduce delays and increase power consumption. Maintainability. While empty modules can improve the readability and maintainability of a design, they can also introduce complexity if not used judiciously. It is important to ensure that the use of empty modules is well justified and that the design remains easy to understand and modify. Best practices for using empty modules. Use empty modules sparingly and only when they provide a clear benefit. Avoid using empty modules in critical parts of the design. Ensure that empty modules are well documented and their purpose is clearly understood. Regularly review the use of empty modules to ensure that they are still necessary and not redundant. By following these best practices, you can effectively use empty modules to improve the structure, maintainability, and testability of your VLSI designs.